Welcome to The Explainer. All right, today we are diving deep into the science of sound. Think of this as your ultimate study guide. We're going to break everything down so you'll be more than ready for any exam that comes your way.
So let's just jump right in with a question to get you thinking. Seriously, how is my voice reaching you right now? I mean, it seems super simple, right? But the actual journey it's taking, well, that's where things get really fascinating.
Okay, first things first. What is sound, really? To get to the bottom of this, we have to go right back to the very beginning. And it turns out there's a single secret behind every sound you've ever heard. Let's talk about vibration. Just look at this ruler on the edge of the desk. You know that sound it makes when you flick it? That twang? That's it. That simple shake is the birthplace of the sound. It's the same exact principle for a guitar string, a drum, and yep, even your own vocal cords. Every single sound starts with some kind of motion.
So that shake has a proper scientific name, and this is a big one to remember. It's called a vibration. It's just a super fast back and forth wiggle. And here's the key takeaway, the thing you absolutely need to know. This is the source of all sound. No vibration, no sound. It's literally that simple.
And check this out. This is a brilliant way to see what's happening. The vibrating tuning fork doesn't just, keep that energy to itself. It pushes it out into the water, and you can actually see the ripples, the waves it creates. Now imagine that exact same thing happening in the air all around you. That's sound. All right, so we've got a vibration, and we know it creates an energy wave. But so what? How does that wave actually travel? How does it get from, say, a speaker across the room all the way to you? It's time to talk about the delivery service.
Okay, here's the deal. Sound can't just travel through empty space. It needs something to carry it. This something is called a medium, and it's just a fancy word for the stuff made of particles, like air or water, or even the wood of a table. These particles are like a massive team of tiny delivery boys, passing the sound energy along from one to the next.
Which leads to the classic science question, right? If you need these little particle delivery boys, what happens if they're not there? What about the total emptiness of space? All those sci-fi movies with the huge explosions? Should you actually be able to hear them?
Well, this awesome experiment gives us the answer. Loud and clear, or, well, not so loud. You put a ringing clock in a jar. You can hear it, no problem. But then you start pumping the air out, removing the medium, getting rid of all those delivery boys. And what happens? The sound just fades away into complete silence. The clock is still ringing, but the sound can't reach you. So that's definitive proof. No particles, no delivery, no sound. Okay, we've got the sound source, the vibration. We've got its delivery system, the particles. Now let's talk about the destination. How does your body take that incoming wave and turn it into something your brain actually understands? Let's zoom in on the human ear.
And here it is, your own personal sound processor. It's an absolutely incredible bit of biological hardware. What we're looking at here are the three main parts, the outer, middle, and inner ear. And each one has a super specific, crucial job in a perfect little assembly line for hearing.
So check out this four-step journey. It happens in a split second. First, your outer ear acts like a funnel, catching the sound wave. That wave hits your eardrum and makes it vibrate, just like a tiny drum. Then, the really magical part happens in the inner ear, where those physical vibrations get turned into electrical signals. Finally, those signals shoot up to your brain, which decodes it all and tells you what you're hearing. All right, but not all sounds are the same, are they? Why is a whisper quiet and a jet engine deafening? Why does a bass guitar sound low and a flute sound high? Well, it all boils down to two main properties of any sound wave: loudness and pitch. Let's tackle loudness first. This is all about something called amplitude. Just think of amplitude as pure power, the size of the wave. A really big, energetic vibration shoves those air particles hard. That creates a wave with a huge amplitude, and our brain hears that as a loud sound. Now, the other side of the coin is pitch, and this has nothing to do with power, it's all about speed. This is called frequency. It's literally just counting how many full vibrations happen every single second. The faster the vibration, the higher the frequency, and the higher the pitch you hear. This diagram makes it super clear. Look, they're two totally different things. Amplitude is the height of the wave. See how the louder sound has a taller wave? That's it. Frequency is how squished together the waves are. More waves crammed into the same space means a higher frequency, and so a higher pitch. So if there's one thing you write down for your exam, it's this. Loudness and pitch are completely separate. Loudness is power, and that's from the amplitude. Pitch is speed, and that's from the frequency. Don't get them mixed up.
Okay, for our final section, let's talk about the difference between a pleasant sound and just plain noise. And even more interesting, the incredible range of sounds that are happening all around us that we can't hear at all.
So we measure loudness using a scale called decibels, or dB for short. As you can see, a whisper is down around 20 dB, a normal chat is about 50. But look what happens when we get to heavy traffic. We're at 90 dB. And that's an important threshold because anything over about 80 decibels isn't just annoying, it can actually start to hurt and cause real damage to your hearing.
And what about the range of pitches we can hear? Well, for a typical person, it's a pretty huge window, from 20 vibrations per second, or hertz, all the way up to a whopping 20,000 vibrations per second. Anything inside that massive range is what we call audible sound.
But, and this is where it gets kind of mind-blowing, that's just our range. There's a whole universe of sound happening outside of what we can hear. Sounds with frequencies too low for us, that's called infrasound. Elephants use it to talk to each other over huge distances. And sounds with frequencies way too high for us, that's ultrasound. Dogs can hear it, bats use it to see in the dark, and we even use it for medical imaging. It's wild.
And that kind of leaves us with one last big question to think about, doesn't it? What kind of amazing conversations are going on right now all around you that you just can't hear? The air is literally filled with messages our ears aren't tuned to receive. It's a pretty humbling reminder that what we perceive is only a tiny slice of reality.